Hey guys, this is Mr. Manor, and I just want to give you a quick summary of ionic bonding when we're looking at the periodic table. So there's three types, and the first type is in the S and P blocks, if we just have single monoatomic ions in the S and P blocks. And we see that these columns have fixed charges. So we need to be able to look at strontium, for example, and know that it's because it has two valence electrons, it's going to have a +2 charge. Likewise, we can come over here to chlorine, and we know that chlorine has 7 valence electrons. It can gain 1 electron to fill up that shell. Chlorine will always have a -1 charge. The only one here that's kind of strange is the carbon family. It really doesn't have a charge. It's more covalent in nature. They don't form ionic bonds. But we have a +1 column, a +2 column, a +3 column, and then the noble gases going backwards the other way do nothing, so 0. A -1 column, so there's room for 1 more electron in those. A -2 column, so there's room for 2 electrons there. And the nitrogen family has a -3 column. And at least those are for the nonmetals above the metalloid stair-step line. So if we take any two of those, strontium, for example, we already did, and chlorine, we can get strontium chloride. And we know, if we know the charges, we know the formula. So we don't need any extra in the name to figure out what the formulas for these are. And we call those our type 1 ionic bonds. Okay. So they have fixed charges. Type 2 can have multiple charges, but it's just the cations, because you'll notice there's not really room for it over here with the anions. And it's really here in the transition metals, because they have extra d electrons, they can form different positive ions. And because they can all have more than one charge, we need to know what type they have. So this is mostly the transition metals. And we would need to know if we had a copper ion, if we had copper 1 or copper 2. So we get Roman numerals that go with those names. And this is a copper 1 ion, and this is a copper 2 ion. So this just becomes part of the name. Now, if we combine that with the chlorine is still a fixed charge. That's fine, but copper 1 chloride is now a different chemical than copper 2 chloride. So these transition metals here in the middle can have multiple charges, except for 2. There are 2 ions, silver +1 and zinc -1. Even though they're not in the columns that have fixed charges, they still have fixed charges. Zinc and silver will always be +1, and then silver will always be +1, and zinc will always be +2. And because they have a fixed charge, they don't need a Roman numeral down here, even though they're transition metals. So the Roman numeral is more about, do they have multiple charges? These two that have fixed charges don't need that. Okay, so this is how we differentiate between those and how we read them on the periodic table. When you see a name, when these all get mixed together, you should look at the periodic table and see if is it a transition metal, I might need a Roman numeral. If it's in a fixed column, I probably don't. And then the third type is polyatomic ions. And that's where we have a covalent molecule, a group molecule, that has a fixed charge. So nitrate is a -1 ion there. Now we can combine these with any metal ion that we want. If we had copper 2 nitrate, copper has a +2 charge, nitrate has a -1 charge, we would need to balance those out. So copper 2 nitrate, if I need 2 of those nitrates, because it has a -1 charge, we need parentheses there. So those two -1s will cancel out that +2, and then we will get our formula that way. So copper 2 nitrate. We can get polyatomic ions with parentheses. Hopefully this helps you navigate these three different types a little bit, especially with the metals in these first two types. You can use the periodic table to help you figure out which version you have.